All right, I think we're going to go ahead and get started. How's it going, everybody? This is like a great turnout. This is awesome. This is like our biggest meetup in this room. We may have had like some that competed with it, but it was only about Kubernetes, because whenever we talk about Kubernetes, everybody shows up. But I think gRPC may be one of those buzzwords, because as soon as I sent out that email, a ton of RSVPs, so it's really awesome to see this many people. I definitely see some new faces. Like, raise your hand if you haven't been here before. It's like half of you. That's awesome. So yeah, it's super awesome. Like, you know, we're a growing meetup. It's really cool to see, like, you know, that energy. So great way to kick off the decade. For those of you who haven't been at the Capital Factory, I'm glad you made it. I'm glad you found it. Hopefully, if you parked downstairs underneath in the building here, you got your parking ticket, and you can get validation by talking to the gentleman up front at the desk as you walk in after the elevator. And he'll give you a validation. It's not free, but it takes off quite a bit of money. Bathrooms are to the left after the desk. If you just head that way, turn immediately left, and then the men's are on the right, or the left, one's on the right. And Wi-Fi is available. It's Capital Factory Guest, and I think it makes you enter like an email address, but you can just make up anything. Just so you know. I just want to let everybody know there is a code of conduct. We abide by the Go community code of conduct. So, I mean, obviously, just be respectful to one another. There's a lot of us packed in a small space. We just need to make sure that we're kind to each other, not discriminatory or any of that. And we've never had a complaint, so I'm glad to say, hopefully it's working. We're mostly, I think, good people. So, and then also wanted to bring attention. There's some posters and pins that were given to me by the Go team. I have a bunch of posters kind of on this back table, like across from the pizza, and some rubber bands, so definitely on your way out. Yeah, they're really sweet. Mission Control, Gophers. So there's 50 of them, like take them, hopefully we get rid of all of them, and some pins over by the pizza. And then I just wanted to bring attention to our sponsor this month, which is Episource, and I believe there's a gentleman that could tell us a little bit about Episource, about hiring, what y'all do. Yeah.
Cool. Well, hello, everybody. I work for Episource. We are a company that has been in the business for healthcare for about 10 years. We have about 6 different products in healthcare. The team I work is called Epi Analyst, and we do processing of data for healthcare data for insurance companies, especially in Medicare right now. So it kind of helps insurance companies to better get paid fairly, whatever they provide service for United States in general. And we are kind of hiring right now for multiple teams, especially in the platform team. We are building a lot of integration with OpenID Connect with Auth0, and building tools that other teams can use and integrate between those projects. And the team working right now is kind of working as a full stack architecture. So we have a lot of JavaScript, React, we have Golang serverless, we have a lot of ETL pipelines with Python, Scala, Spark. A lot of stuff right now is kind of getting like written from scratch. So there's a lot of opportunities to actually be able to give your opinion to how the company and project is going in the next quarters. And there's a lot of opportunities open right now. And if you guys want to hear more about those opportunities, just let me know. Yeah, thank you.
Awesome. Well, thank you all so much for the sponsorship. And you know, they provide the money that funds our pizza and our beer and everything. So I'm really glad to have them on board. Also, Capital Factory. Obviously, you're here. You know you're here. They're an awesome co-working space, and they're kind enough to give us this room once a month. So anyway, we have an awesome speaker in this week. We're lucky enough to have Corey from Gopher Guides here to share with us about G Rpc and G Rpc Gateway. It's definitely a topic that, you know, I was just talking to Trevor last week and about, you know, what we should be doing with the meetup this year, and I was thinking about doing a talk on G Rpc, but now I don't have to. But you know, for the rest of the year, we have to fill a bunch of speaking slots. We haven't really planned out this year yet, but you know, last year in January we did a call for submissions during the January meetup, and we almost filled the schedule. And I'd love to do that after Corey's talk. So definitely, if any of you have thought about speaking before, or if you have before and you'd like to share something, you know, we actually have some topics in mind. We'd love to help you if you're a first-time speaker to, you know, break that mold and join us and try to speak about something. You know, we live stream. It's really an awesome thing to have, like, just on your resume or whatever. So looking forward to doing some talk submissions or talk about, you know, our process there after Corey's talk. But anyway, I think we'll go ahead and get started. And does anybody have any questions before Corey's talk? Or any other announcements or anything, Trevor?
No, not till the wild rumpus of the schedule back.
Awesome.
So I encourage everyone to stay for it.
Yeah, everybody, yeah, absolutely.
If you eat pizza, that means you have schedule later on. I'm just saying. We didn't tell you that earlier, but.
That's absolutely right. All right, well, welcome, Corey.
All right, quite the full house tonight. So this is fantastic. All right, so I'm going to start off with some of the welcome stuff here. I can get my mouse to work. There we go. This is should be a little faster than this. Okay, so welcome everybody. All right, so I'm just going to go over some basic information. First of all, I'm Corey Lanou. If you need to get a hold of me, this is how you do it, right? So LinkedIn, GitHub.
I don't think anyone can see that.
It's okay, because I'm going to share the slides with you in just a minute. So we'll make it bigger. All right, so if you want to follow along on your computer, simply go to this link right here, gopherguides.com/redeem/Austin-2020. What this will do is actually get you all the slides and the material for what I'm going to present tonight. Now, what I can tell you is that I'm not going to cover all the material in the outline because I'm mostly going to cover about the gateway, but it does have everything from the beginning of what are protocol buffers, what's G Rpc, how to create protocol buffers and generate them, how to create a G Rpc system, that kind of stuff. I'm going to kind of start further down the stack tonight in the gateway, but you're certainly free to use this information to kind of level up and kind of learn a little bit about G Rpc and protobufs and along the way. So, all right. So now you have access to that for the rest of your life, so enjoy. So I'm going to be presenting literally out of the same thing that I just gave you. We're not going to do introductions because I usually do that when I do the workshops, but we probably don't have time for that. All right, so I'm going to cover a few slides out of each of these prior ones right here, just to kind of give an overview. So if you're new to gRpc and Protobuf, at least you can kind of follow along for the gateway stuff. And this chapter really is only about installing all of the actual tools. So the first thing you're going to need if you're going to do gRpc and Protobuf is you're going to need the actual Protobuf generator, right? So you can just go to the releases and you can basically find whatever one that is going to fit your need. So I'm on Mac, so I would grab this one right here. What I like to do is when I grab the zip file, kind of give you an idea what's in here real quick.
64?
Is that what I grabbed or no?
No, you probably do.
That's okay, it won't matter. I want to show you that literally there's a bin directory and that's the Proto-C compiler. So when you see me running Proto-C tonight, that's what I'm running. I recommend typically putting this in your GoPath bin. And for those of you that don't use GoPath anymore, it'll be your Go Home directory /bin. And that way you can just run Proto-C from wherever you want and your Go tooling will pick that up. So that's kind of that piece right there. You may need some of these actual libraries. You're going to hear things about the Golang Protobuf and GoGo Protobuf. I don't know if GoGo Protobuf is as popular as it used to be because I know the Golang Protobuf is much more idiomatic for Go now. So I think most of us are using the Golang Protobuf. But if you want to use GoGo Protobuf, it's a great article up there, kind of explains the difference. But you're going to need the plugins for it. So if you want the Golang Protobuf stuff for Proto-C Gen, you actually need to do a go-get of this. So you'll need this as well for Proto-C. If you don't have this, it won't find the plugin, and then it won't actually generate the Go code from your Protobuf. So you've got to have both of these to make things work. And then you probably want to get the gRpc library at some point because you're probably going to reference that as well. Which brings us to basically a Protobuf file. So what are Protobufs? Protobufs, in fact, am I skipping ahead? I can. So let's go into what's a Protobuf real quick. The rest you can catch up on your own there. All right. So protocol buffers are just really the next step in data formats, right? So if you think about JSON, basically Protobufs are a little bit, well not a little bit, but quite a bit faster. They're a packed data format. There's plenty of seats up here if you want to sit down. Come on up. Don't be shy. So basically just think JSON but much faster. And what's nice about Protobufs is they preserve type information, right? So they're basically type safe. So if you're doing Go and you're already in a statically typed language and you really like the type safety, you're gonna like Protobufs too because they're also type safe, which is fantastic. Simple anatomy of a Protobuf. They look something like this, right? So they have a message which is analogous to a struct in Go. They're going to have their fields in there, so they're going to name them backwards. They're going to be type and then field name. So with this person, you've got a field called string. You've got a field of type string called name, and then you have these odd little things here that are the field numbers, and they basically are numeric 1, 2, 3, 4, 5. You don't have to keep them in order. You just can't reuse them. All kinds of stuff about Protobuf definitions that I'm not going to go into, but that's what a Protobuf looks like. So from there, you can run the Proto-C compiler against this Protobuf, and you get all your Go code. All right, so that's what happens, and then you can use that in your program, which we'll cover that when we get to the gateway. So a lot more stuff there about Protobufs if you want to learn it, but again, that's not what the talk is about tonight. So then what is gRpc? So gRpc is basically the network framework, right, to serve and communicate with protocol buffers. So gRpc is a really, really fast, basically a remote procedure call framework. So when you think about a remote procedure call, what is that? It basically means that I run code on my computer here, and I make an actual function call, and I don't know that it's going to actually go across the network and work on some other system, right? It's going to make a remote procedure call, but it's like I'm programming locally. So that's what an RPC call is. Now, RPC calls have been around since I started programming 20-some years ago, so they're not exactly a new thing, but this is just using gRpc to do it. All kinds of stuff in here about gRpc. My favorite one is, what does the G in gRpc stand for? Well, every release it changes. So if you ever want to know that, now you're educated on gRpc. All kinds of stuff about how it works, but fundamentally I just want to get to the service definition. So this is what a service definition looks like. We still use protocol buffers to define the gRpc service. So in this case, we basically have a service. It's called my hello service. I have an RPC call. The RPC call will say hello. It's going to take a hello request as an argument, and it's going to return a hello response as the return value. Every RPC call in gRpc takes a single argument and returns a single argument, okay? And the reason we do that is because gRpc is cross-language compatible, right? So if you write it in Java or Python or C# or Go, every one of those languages have the same characteristic of everything can take one argument and everything can return one argument, right? So that means it's compatible across all those languages. That's kind of the big piece there. But that's fundamentally what it looks like. So at this point now, you can define an entire service. I can define what my RPC call is going to be, and I can define now my messages or the actual arguments and the return types are going to go across it. These are the basic building blocks of gRPC. Now, this will again generate more stub code for me that I can then go ahead and build up into my service. All right, so I spent a long time on that too, but we're not going to. So, now that you've got the fastest primer on gRPC and protobufs in your entire life, now we're going to talk about the G Rpc Gateway. And I'll slow down a bit. All right, so the G Rpc Gateway is just a plugin for Google protocol buffers and for the compiler for the Proto-C. It's going to read the protobuf service definitions that we created, and it's going to generate a reverse proxy server that translates the RESTful HTTP API into the gRPC actual call. So when we think about this, we want to use gRPC for a lot of reasons, but sometimes we're kind of stuck with a migration pattern. Like if we have a RESTful API already, we can't just get rid of it, right? We got to have some type of migration plan. So a lot of times this is going to be very helpful for this. So gRPC is great, but like I was saying, sometimes we have to maintain backwards compatibility. The nice part about this is we have a RESTful design. Even languages that don't support gRPC can now use our gRPC service, right? Because it's just RESTful. So pretty much everybody can do a RESTful call. So that's kind of a big benefit for even more legacy languages or languages that simply don't have the support that we want to have. And you're going to see that with just a very small amount of configuration, we can generate that reverse proxy very quickly. So how does it work? And this slide is actually out of the gRPC ecosystem. So it works by this. So we've got that proto file that we have, right, which is our definition. It has that Protobuf definition and the RPC definition. And when we generate this with Proto-C, it's going to create the gRPC Gateway code. It's also going to generate the Proto-C code. And from a client standpoint, what's going to happen is you've got the API up here that the RESTful is going to hit. It hits the reverse proxy, which then actually has a connection to itself as a gRPC client. So that's how the reverse proxy works. It actually has its own connection in the reverse proxy. So there's a little bit of latency right at that point. So you're going to have a little bit more overhead on the RESTful endpoint, but not very much. It's still pretty efficient and pretty fast. And then finally, that just goes ahead and calls your gRPC service. What's the advantage of this? It means I can write a gRPC server, go ahead and tell it to generate the RESTful endpoint, but only maintain one set of code for gRPC. I don't have to ever worry about maintaining for the RESTful endpoint. So that's actually quite the benefit. All right, so dependencies, you're going to need a few more at this point. You're going to need the Proto-C Gen gRPC Gateway. And if you're using Swagger, or if you wanted to generate Swagger, which you will want to do, trust me, even if you don't like Swagger, don't worry about that. You're still going to want to do this. Then you want to use this plugin as well, and I'll show you what. All right, so we're going to look at a very simple service. So this is my proto definition. I've got a user service, and all I'm going to do is call add user and give it a add user request, and it's going to return a user. And then I'm going to have list users, right? So it's going to list users, list user request, and then it's going to stream back the users. So we didn't talk about unary and streams in gRPC, but that won't affect what we're doing tonight. All right. So then you see my add user request actually has no arguments, right? Doesn't take anything at this point. And my list user request has no fields as well, but my user is a single string of an ID. So this is a very basic protocol, right? Basically it has a user, it has an ID, and I'm going to use UUIDs at this point to go ahead and do that. So now that we have our proto file, what do I have to do to make this create a gRPC gateway? Here's what I have to do. So at this point, I have to import in my gRPC file the annotations proto. All right, so I need that because I'm going to start giving it annotations. And now I need to add an option for each of my requests. So before, remember, I just had my add user request that had nothing with it. Now I'm going to give it an option. It's always going to be this line of code right here. And then I'm going to tell it, I want you to post, right? It's going to be the post for add user. And here's my route, /API/v1/users. Starting to look a little RESTful, right? That's what we're looking at there. And then I'm going to tell it, I want you to get the content of that post from the body, because I'm going to post JSON, right? So I'm going to post it to the body, so I want you to read the body at some point. Now we'll see where this becomes more important when I start to send data, but for now we're just going to tell it that. So now I've got my list users request, and I'm going to give it the same option, right, up here. And then I'm just going to give it my route, so I've got my verb of get, and then API v1 users. Again, looks a little RESTful like we would expect. So this is what the entire file now looks like, right? So if you remember from before, this is what it looked like, very sparse. And now we've filled it in, and we have, the only thing we added was this import here, and then we added this option, and we added this option, okay? At this point, Protobuf can now generate all of my code for the reverse proxy, all right? So this is pretty cool. All right, so now what do we do to actually generate the code? So you heard me tell you that you need this Protobuf generator, okay? So you've already downloaded this. The -I basically stands for include, so I want to include my service directory. That's where my Protobuf file actually resides if we looked at my code. In fact, maybe I should just do this real quick. Vim, directory. All right, so in my service directory, this is my proto file, right? That's actually, let me go up to this one. This is the one we're looking at now. We're looking at O2. All right, service directory. There's my proto file, right? That's the one I just talked about. So when I'm running this protobuf command, I'm telling it to look in that directory. That's what I'm telling it. Then you need to go out, and if you've done grpc, you actually are familiar with this command. It's something you do all the time. You're going to tell it what plugins you want, and for this one, I want you to generate all the grpc code. We're going to use path source relative. That just makes it so when it generates all my relative paths, which is what I want. And also, I'm going to tell it I want to use .service for my relative pathing. And then I want you to actually generate it from this file, which is my service/user_proto. So that's a big command, and I get that. So that will go ahead and generate basic grpc, but I also want to now add in the grpc gateway. So to do that, I have to add more stuff, and it's too long to fit here, so I broke it down over here. So now I tell it to look in the service. I have a third-party APIs directory here, because if you've ever worked with protobufs, trying to have it reference where all the Go get stuff comes in was difficult with GoPath. Now that we've got rid of GoPath, it's almost impossible. So at this point, you just say, you know what, I'm going to create a third-party directory. You're basically vendoring at this point, right? And so you put the Google API stuff in here, and then you put in the G Rpc Gateway. And this is all of your Protobuf definitions that you get from their libraries, which are publicly available. So all I'm doing at this point is saying, you're going to need to look in there for more Protobuf definitions from the G Rpc Gateway and from the Google API. This doesn't change at all, but now I have to tell it I also want you to generate a G Rpc Gateway out file, right? And that's going to go into my service directory as well. And then I'm still telling you to generate from there. All right. So this is a big command. You wouldn't come up with this on your own. You're going to come up with it because you're going to find other articles like this that tell you how to do it. All right. So that's everything I need at that point. All right. So now I have to spin up the actual service. So if you've ever spun up a gRPC service, it's actually fairly simple. You're going to create the new G Rpc server. This server right here is a server that I've created. So if you've ever done any gRPC coding, it's going to look something like this, right? So I've got a server. I'm just going to keep a list of servers right now. We're not going to back it with a database. Here's my add user endpoint that the gRPC is going to go ahead and map to. So everything in gRPC takes a context, and then it takes the request, right? Remember I had an add user request, and then it returns the user, and then it returns an error.
Or can you blow it up just a little bit?
A little bit bigger?
Yeah.
How's that?
It's okay for me.
How's
I
that?
might want to knock off nerd tree also.
Get that way.
There.
All right, how's that? All right.
Great, thanks.
So at this point, the code that's in these endpoints here is just the Go code, right? So this is me, doing my lock, so I don't have any race contention. I'm going to go ahead and manufacture a user here. I'm going to append the users to my internal database, and then I'm going to return the user, right? That's all I'm doing there. And list users is my other endpoint I created, and what does it do? It just goes ahead and ranges to the user and streams them out to my gRPC endpoint. So that's all the code is on the server there. But if I'm looking at how I want to fire the server up, this is your basic piece right here. Actually, go back to here so you can see it. If you're firing this up, so this is the server that I just showed you right there, that's mine. And then you always have to register your service with the gRPC server. So this is me saying, take the server for gRPC and then register it with my server that I created. And that does all the interface magic mapping to make sure that you've satisfied everything that you told the protobuf you were going to do. So if you didn't declare those endpoints that I just showed you, this piece of code would fail. That's standard gRPC. So then I go ahead and I just log out that I'm going to start up the service on the listener address I provided, and then I serve it, right? So that's what a basic launch looks like. But if I'm going to launch the gRPC Gateway, I now have to do a little bit more work. So what does that change look like? Oh, I'm actually on this page. So if I want to launch the gateway, you have to do this runtime.newServMux. I'll open up the code for this. And this one's kind of confusing because I'm in O1 here. I'm in O2. Yep, I can do that from here. All right. So it's the runtime.new server mux, not to be confused with the Go runtime. It's the G Rpc Gateway runtime package, right? So great naming on their part. So if you ever see that, that's not what you think it is. That's the runtime from G Rpc. I'm going to give it dial options. I don't have any certificates in place, so I'm just doing insecure. Don't do this in production. And then you have to register that user service handler from endpoint. Now, where does this code come from? This code is what was generated for me. So this import right here is the service that the G Rpc Proto-C generated, and I'm just going to use this endpoint. You got to give it a context. You got to give it the mux that I just created, and then I got to give it the address I want to launch it on and the options. Okay, so that's all I have to do there. And at that point, I can use just a standard HTTP listen and serve and give it that muxer. This is all. Yes.
What is the context?
Context? So context is basically, we use this in Go all the time for we use it for concurrent programming, and it's a way that you basically send around like metadata, like session IDs, user IDs. If you're doing a lot of like network programming and you have distributed systems, you'll do like an origin ID and a hop ID to track across, like, you know, when I'm spanning and tracking all my tracing across networks. And then it's also used for canceling, for deadlines and things like that, so deadline propagation, things of that nature. That's primarily what context is used for. So, yes?
So could you share the options between the G Rpc service and this
Oh, the RESTful gateway?
Yeah.
I don't know the answer to that. I'd have to look. G Rpc Gateway is still somewhat new to me, so I'm still learning it too. So I'm not sure. I'd have to find out. Any other questions while I'm paused? Yes?
How about middleware, like in standard HTTP, you would put that on your router?
Mhm.
Would you do that inside of your G Rpc, like add some filters?
So G Rpc has a concept, what they call interceptors. And interceptors are literally middleware. So what you would do is you would define your middleware before you fire your actual service up. And then you would chain all your interceptors together. And then you would just basically dial your spin it up and give it that as an option. So and interceptors are actually pretty easy to write. They're pretty powerful. And if you look for gRPC ecosystem, you'll find a GitHub repo that has a whole bunch of interceptors already written, like auth interceptors, logging interceptors, like the whole works. So you don't have to invent the world. They're already out there for you. Anybody else? All right. That was a lot of questions. Don't hesitate to stop me if you have more questions earlier. All right. Looks like they were building up. Okay. So at this point, what have I done? I've created a gRPC service. I've generated the gRPC gateway, and I've actually wired it in. So what's left to do? Let's go ahead and fire it up. All right, so let's do this here. Two, I think. Right. Wanna be? Sure, okay. Go run cmd server star go. Get it right? Yeah, that looks right. Okay. So what I did now is actually log out a little bit of stuff, and you'll see that I actually started the gRPC gateway on port 8080. So if I did things right, I should be able to grab this curl command, right? So I'm going to post a user to this endpoint, and it goes off the screen. We'll grab this, add even more stuff to my screen. Ta-da! It worked. There we go, right? We got the response back. So this shows that it did indeed hit that endpoint. And then let's go ahead and curl this right here. And we can list the user back. Ooh. It would help if I didn't have, that's not what I copied, is it? Live coding for the win. Okay, and there you see that we got the result back, right? So this is actually using the gRPC gateway and talking through the reverse proxy and translating to a gRPC request and using the gRPC server, right? This actually works. Okay, who likes to do all their testing with curl? Nobody. No, come on, nobody does. Okay? It's great for some simple stuff, but when you start doing a lot of stuff, we need something a little bit better than this, right? So here's where Swagger comes in, okay? Why do we want Swagger? We want Swagger because I want to use some open API framework to create a really nice GUI for me to actually test this out. So now this is where we're going to change our profile to use the actual annotations for the Swagger. And then I have to add an option in my proto file that basically says I'm going to use Swagger. And tell where my documentation is. I'm lying here, by the way. It doesn't exist there, but Swagger doesn't know that. And the description of it, and then the scheme, right? All right, and then I'm going to use the Open API UI project. Basically, they have a distribution folder, and I copy this entire folder, and I serve it as an asset. All right, so I'm going to drop this into my own system here as a folder, and I'm going to serve it as an asset, which I'll show you in a minute. And then to generate the Swagger, I have to add yet another argument to my Proto-C, right? Got another one right there to actually tell it I want you to generate the third party into the third party open API directory, okay? So what does that look like? Got too much stuff open here. Exit that again. All right, so let's get into nerd trivia here for a second. All right, so that third party open API directory, right? This is all that stuff I told you that I just dropped down. And then it generates this user Swagger JSON, right? So that's what generates for me. So that's how when I open up this static directory, that it actually knows to grab this file now and serve it as part of that framework. So if you're wondering how it kind of got injected in there, that was, I told it to drop it to that directory. So I cheated a little bit, but it works fine. All right. So that's one piece of it. But now how do I serve those assets, right? I want to be able to use those assets. All right, so now it gets a little more complicated because I have to do a little bit of my own muxing at this point. So I'm going to change the launch gateway system. All of this code stays the same up here, right? I'm going to go ahead and create my muxer just like I did before. I'm going to go ahead and wire it in. But now I want to serve this third-party open API directory, right? Now, if you've done any type of web development with Go, this will look fairly familiar to you. I'm just telling it it's an HTTP directory, and then I'm going to call the file server on it, right? At this point, I've got basically a HTTP handler at this point is all I've got. That's what my assets are. It's an HTTP handler, and I can literally just serve that. Now, I could actually use a real muxer, but I'm too lazy to do that. So I'm going to create my own router, because that's what we all do, right? And all we have to do for that is, if you're familiar with the HTTP handler func pattern, this works out really nicely. If you're not, don't worry. Someday you'll get familiar with it like I had to. And all I'm doing at this point is saying when the route comes in, if it has a /API, I know that that's a RESTful JSON call, right? I know that that's supposed to go to my JSON RESTful gateway. That's where that's supposed to go. If it's not, then I'm simply going to serve my static assets, right? So API path, I route it to my muxer. This is me doing my fancy routing manually. If you've done web development, you're laughing at me, but this does work. And then I serve my assets otherwise. Yes?
Quick question, like to back up just for a second. On that, like at the top there where you had it, or sorry, the screen you were just at. Yeah, here, the register user service handler from Endpoint, that part was a function that's generated from the
Proto-C.
Proto-C, got it. And then, so like where is, if I wanted to like just interact with this, like not using the gateway at all, but just interact with Proto-C, like in the protocol buffers, like where, like I guess I maybe missed the part of where that's like active and live that I'm listening to.
Right, so the G Rpc server is actually, let's just open this up here real quick. Okay, so I've got a couple of things going on here. Oops. All right, so I've got my launch service that I'm doing. This launches the standard G Rpc service right here,
Okay,
right?
I see.
So this is launching that. I'm launching, I think, on port 5051.
Okay.
And if I had a client built for this, which I don't for this one, but if I had a client built, I could literally call the client
Directly
at this
talk to
point
that
and
using
talk to this G
Protobuf.
Rpc standpoint as pure Protobuf at this point across the G Rpc framework, right? So
Got it.
this is fired up and it is working.
Okay.
But I'm primarily focused on the service at this point, which is why I'm showing how to wire that up.
Makes sense. And then sorry, just one more continuation on the, and then when the gateway is making a call to the Protobuf service, is it actually making like a full HTTP call, like going back out and back into localhost, or is it all kind of internal? into
So
Rpc?
it's going to use whatever address it dials on. So this
Okay,
address that
so
you give it,
5051 in this case.
right? So this address that I give it here, this G Rpc service address, right?
Yeah.
If it's a local host, it's going to dial on local host. It'll actually create a G Rpc connection behind the scenes and actually dial itself.
So if you have like, so basically if you had like, you know, like firewalls or whatever set up, you would be able to dial yourself on port 5051
Yep.
or whatever it is.
Yep.
Got it. Thanks.
You could run it as a separate process then too?
Absolutely. Yeah, I'm just firing up in a single binary. You could actually have your G Rpc service as one microservice and the gateway is another service. You don't have to bind them together at all.
That might make sense if you wanted to scale them separately.
Absolutely. Yep, not a problem at all. You did have a question. You gave up?
I was gonna suggest showing that, if people were confused, showing the generated code for the service itself.
Oh.
Oh yeah, that'd be great.
Yeah, so if you want to see the generated code, this is the actual user.pb.go. So this is all the code that actually got generated. Notice it says generated by Proto-C. Do not edit. Okay? Because if you edit this code, it's just going to get overwritten. All right? So that's where this code comes from. And that's where all these definitions come from. Your add user request. it generates everything. And there's a lot of really gobbledygook code in here too. The only way I look at this code is I fire up Godoc locally. So I don't know if you've ever done that, but if you fire up Godoc locally, this is a really easy thing to read. If you try to read through the source code, it's generated code. It's really not meant to be human readable. It can.
Generated Java though or something. It's not terrible.
It's not terrible. I mean, as a Go developer, I didn't have a problem reading through it. But if you pull it up as a Godoc, it's all perfectly, because the file's not organized the way you think it is, so you really got to hunt for stuff. Like I like to define my interfaces first and then my concrete types next to them. No, they define the interface and somewhere way over here is the concrete type that satisfies it, right? So it's really kind of cumbersome to look at manually. But if you fire up Godoc, it's just beautiful to look at. And so if you ever wanted to know, like, well, how did I know that I had to call, oops, this way back up here. So everybody always asks me, like, how did you know you needed to make that call? I had to look at the Godoc, right? Like it generates that for me, and that's, I know to look for that now because I've done it. But the first time I was like, I don't know what I'm trying to call. And the documentation I looked at generated a different service, so it was a different name, so it doesn't match mine, and my code doesn't compile. Yes?
Sorry, last question for now.
You can have plenty of questions, it's fine.
Okay, great, perfect, okay. You opened the floodgate. So, as far as like registering this with like a build process, is general like best practices to kind of you generate and check this in, or do you make that a part of your build process, like that executes the Proto-C?
So you should absolutely check this file in.
Okay.
And you want to check it in because you want to make sure somebody else doesn't use a improper version of Proto-C or something accidental.
Okay.
And you would see all that code churn. You'd be like, wait, hold on. Like, why did this proto file just dynamically change? Because the Proto-C compiler from version to version generates pretty significantly different Go code.
Okay.
And so it was really problematic on one of the teams I was working on one time because we didn't all have the same Proto-C generator. So there's a tool from Uber that actually ensures that everybody's got all the same Proto-C libraries, the Proto-C generators, like everything, so there's no accidental code churn.
So even though it's like generated code, you may recommend checking this.
Absolutely checking it.
This generated code in.
Absolutely checking it, no question. Yep. You want to make sure that what you're using is what gets shipped out to production. You don't want to hope your build pipeline pulls the right version of Proto-C compiler, because if that gets out of sync, you don't care. Like your code's checked in.
Got it. Okay.
Okay, awesome. All right, so where was I here? Oh yeah. So this was me actually serving my static assets at this point. So this gets a little more difficult. I showed you how I did my routing. And then now that I've got my router that I created here, my really handy dandy router, I can just do listen to serve, and guess what I give it? I give it my router, right? So not overly complicated. If you've done web development, this should look familiar. If you haven't done it, I get how it's completely foreign to you. It's just, Go does things different. All right, so let's fire this up again. Training. I should have a shortcut for this, shouldn't I? Source gateway. I believe we're in 03. Run server cmd server star go. Please work.
Do you have the alt period hotkey where it'll bring up the latest argument?
I probably do. I've never invested enough time with the command line like I should have. It's kind of embarrassing. Okay, so what did I do this time? I fired this up, and I have to actually command R because it aggressively caches this. Ta-da! Now here's my gateway endpoint, but I'm serving static assets, and because I'm using Swagger, look what it does for me. I don't have to use curl anymore. So now if I want to post something to it, this tells me all the information about it from Swagger. I say, let's try this out. It doesn't take any arguments right now because I'm purposely not doing anything. And I say execute. And then here's all my information. Here's my curl. And here's my response body. It really did work. And then if I want to go ahead and list out the users, I can say try this out. I can say execute. And we can see that this is really hitting my G Rpc endpoint, right? How cool is that? All my documentation's there. Really nice UI to use. I didn't come up with this, by the way. I watched Johan do this at GopherCon UK last year. And I was like, this is genius. So anyway, so this is now I have this little piece of this puzzle solved for me to do all my testing. So now I don't have to use curl or remember any of that. All right, any questions so far? Am I doing on time? Ooh, better kick it down. Okay. All right, so the one last thing that I get really frustrated about is all the stuff that I have to remember to generate all the Proto-C. And now the other thing about this too is I really like the fact that Go, when I say Go build, is a single static binary and I can just throw it anywhere I want. But now I have this third-party directory I'm serving off of the directory, right? Well, that's not really desirable because now I'm going to have to ship that along with it. And now I have to communicate to DevOps that when you deploy this binary, please ship these files with it, make sure it's in the right directory and all this kind of stuff, right? I don't want to do that. So I'm going to use a little tool that Raquel created called Static. And all this does basically is you can sell it to take this directory right here and create a Go file that will be a binary representation of all of your bytes in that folder. And you can literally now load that and bind it at runtime and serve it like it's a real directory. So this is kind of neat the way that works. So when I run this command right here, it's going to create a static directory for me, and it's going to put in the Go file that represents all of my actual files. Now I have to register this with kind of this side effect import in my file, and then I need the FS to do that. So now instead of serving, you saw back here how I was serving this assets like this, right? That's how I was serving assets before. Now with static, I just basically say create the new static folder that I wanted, that I just had it generate, and then I serve assets like this, right? So now when I do Go build, guess what? All of my assets are packed in with that same binary, and I can ship that one binary off. I don't have to worry about any of my assets, right? It's going to serve effectively from memory at that point. So that's actually pretty slick. That works out pretty well. It doesn't work for really big projects, but a little one like this works perfect. All right, so that's all my boilerplate I need now to actually ship something that I can use in development. Now you wouldn't want to ship this gateway to production, right? Having this user facing, but it's just nice to ship around to your friends and play around with it. Any questions before I go to the next part? Okay, so I like to make really good use of Go generate. So right now I've got two things I have to remember. I have to remember my Proto-C command, which is big and ugly, and I have to remember to generate my static files. And I don't want to have to come to this project 6 months later, because that's when I end up getting back to it, and go, oh, what is that command again? I can't remember that, right? It's really frustrating. So we can use Go generate. So basically we can take this command right here. I can create an empty file called user.go on my service directory. And then if you've ever done this, you can do this pragma at the top of any Go file, and it's Go generate, no space between the slash and the Go, or it won't work. And then any single command you want, you could shell out and tell it to run a make file, you can do whatever. Yes?
Doesn't need to be in the top of the file, it can be anywhere.
What?
Go generate pragmas can be anywhere in the file.
I've been lied to my whole life. I did not know that. Okay, that's fan. I was told it always had to be at the beginning. I've just never tried it anywhere else. Thank you for that. That's fantastic.
I think build tags have to be at the top.
Build tags have to be, but I thought all the build tags are pragma, and I just assumed all pragmas had to be at the top. That's crazy. Can I have more than one generate per file?
Yep.
No way. All right, I'm learning so much. I'm glad I came tonight. All right. So this is basically Go generate at this point, and then the way you actually run Go generate is you just, well, the other one, I'll get to that in a minute. Then I also want my static stuff to generate too, right? So I want that to happen. And now that I know I was educated, I could have put this all in the same file, which would be really nice, because when you run Go generate, which is this command right here from the top level, it's going to find all the generates and run those commands, right? But what happens if my static bundles before my Swagger generates? It's going to bundle my old assets, right? Which I've had happen a couple times. So that was kind of frustrating to me. So I'll actually rework this now that I've got more knowledge, and actually make this a single Go generate file and make sure that the order is preserved. Because the other thing you're supposed to do too is actually delete the static directory before you generate your static assets. So kind of some moving parts there. But this, now what I like about the Go generate, by the way too, this gets checked in, right? So anybody that comes to this project, they don't have to know makefiles. Why don't I use makefiles? Anybody know why I don't use makefiles? I love makefiles, they're fantastic. Why don't I use them?
Because make on Windows makes you want to stick forks in your eyeballs.
There you go. He said it a little more elegantly than I would have, but yes, that is why I don't use makefiles. The whole point of Go is that it's cross-platform, right? Let's not go ahead and stick somebody with something that's not cross-platform. That's not cool, right? That's why Go generate exists. So let's go ahead and use the tools. All right. So generate the world. All right. So now we want to add a little more to our code. We want to extend it a little bit. So now I want to add an email field to the user, and I want to have the ability to retrieve a specific user. So this is as easy as going into my add user request, telling it it's going to take an email. I'm going to now tell my user type it's going to have an email as well. And then I just have to go and add a G Rpc endpoint. I've already got one for add user. So at this point I'm going to say make sure you stuff the email with it as well, right? And then if I run Go generate, I'm pretty much done, right? Like I'm pretty much there at this point. I also have to add the add user get, so I have to do that. So now I want to do an RPC call for get user. I'm going to tell it it's going to take a get user request. It's going to return a user. I'm going to tell it that it's going to route to this verb right here. And then here's the magic of how that works, right? So with RESTful, we're used to inserting kind of that ID in our route all the time. So we can use the curly brackets when we define our route here. And then we can say user ID is going to be the variable I want to use. Now, there's some convention here. When you do the get user request that I defined up here, this has to be a user ID that matches this user ID, right? If I do user dash ID instead of user underscore ID and it's not gonna match, it's not gonna work out for me. So the user ID in the path up here, this argument has to match this argument. If it doesn't, the convention won't work, right? So a little bit of convention. I'm gonna create my get user endpoint on my actual Go code. Here's my endpoint that's gonna map to that. I'm gonna use a linear search to loop through all my slice of users. If I find it, I return the user, right? If I don't find it, anybody ever use the status library with gRpc? Super cool. You should never return any error, by the way, even a nil error, without using the status in gRpc. It's kind of neat. So basically all I do is I just give it a status not found. All right, so that is all of that piece right there. So at this point, let's see, I am in...
Can you go back one real quick?
Yep.
Like one before this. And so this is the protobuffer, essentially like the contract, like the .proto files.
Yep.
Is what this is, right?
Yeah.
Okay.
So if I actually go out to here now, exit. All right, so let's close this. We're all the way down here now. All right, so let's take a look at our user proto, right? So this is what our user proto looks like now. We've got all of our imports for our annotations and our Swagger. We've got our Swagger definition up top. We've got our user add service, user service add user, get user, list users. And then we've got all of our message requests down here, finally with our user, right? So this is the whole protobuf file, all right? Then in our command, we have our main server, right? And then I've got my endpoint for add user, which I just added, right? Or I didn't add, sorry. I added the email to it so I can actually store that. I have the list users, which I didn't make any changes to at all. This is still just gonna work. I've got the get user now, which is gonna take the get user request and do the linear search and try to find the ID of the request that I got in from the users I have internally. And then if I didn't find it, I return my nice status code. That's it.
And is the user.proto is actually generating like the Go class for
Here is so if I look at type user, there's my user struct, right? And it generates that new email, tells me all the protobuf signatures I have on it, so on and so forth. And the gateway does the same thing, right? All my stuff is created in here, right? So all the stuff for the gateway, everything's there. So, all right. So let's actually fire this up now.
I got a quick question for you
Yes.
too. This static tool that you use, what is that checked in? Like, are you version controlling that?
So that's a Go mod question.
Okay. Regardless.
Technically,
on that,
yes.
If you run Go generate without it, does it give you a pretty clear, like, I don't know, indication as to why the Go generate pragma failed to run?
So if Go generate fails, it's going to literally give you the same output as if you ran the command just directly, right? So you get the same output. Yep. All right. Training, distributed, Rpc. Source, 06. Go run. Getting better at this. Oops. Oh, that's not the one. CMD. Just said I was getting better. Well, I'm in 06, right? Yeah. Okay, there we go. So now I can come back to my Swagger UI. Again, remember I said it aggressively caches this. Let's close this back down. All right, so do I have, yes. So now I've got my new get user endpoint, right? So I've got my post, so let's go ahead, and now you see I can put a string in there, so I can try it out. I can say, I now want to create it with an email address. All right, I can go ahead and execute. And then we see that it works back there. Here I'm gonna get my ID. All right, and then I'm gonna come up, I'm gonna say get here, I'm gonna say try it out. Now because this knows it takes a, oop, that's not the one I wanted, sorry. Where am I here? I want this one. This one actually knows I take a user ID, so I give it the user ID. And I missed a piece, didn't I? Copied that, where did it go? Oh, come on. Cut and paste failed me. Oh, maybe it was off.
No, you're good.
Okay, I guess I'm good. All right, and there we go. And there it works, right? So there's now my get endpoint with the actual specific user ID being requested. So that's the big piece of setting all that up. There is one last piece I'm gonna go into. I know I'm running a little long here, so I apologize. Added user get. Field mask. So we all know about patch requests, right? When it comes to RESTful design, I want to basically patch a user object, and maybe I just want to update one single field. That's all I want to do. So we actually support patch requests, believe it or not, in G Rpc Gateway. Otherwise, it'd be fairly useless probably. All right, so what do I want to do here? So now I want to create an RPC endpoint called update user. I'm going to give it my endpoint. I'm going to tell it it's a patch this time, right? So I'm going to tell it it's a patch. I'm going to tell it you expect the user ID here. And then now you're going to see I've added some more Swagger documentation. So you can add a lot of Swagger documentation as well. So this is me being a better citizen to Swagger at this point. Here's the new convention you have to know. So I've added a couple things. I added a timestamp as well. And I don't want the timestamp to be edited. And I don't want the string ID to be edited. To do that, for the annotation standpoint, you have to put this above each field that can't be edited in a patch. Okay? So this is what you have to do. So when I do this at this point, this is going to now enforce it at the Swagger level so that it's going to know that I can't edit this, right? Like that's the key. All right, so I make those changes. I have to create my update user endpoint. I'm going to do the same thing. I'm going to do a linear search to actually find the user. If I don't find the user, I'm going to return a status code of not found. And then here is how I use the mask. I'm going to use the request. I'm going to call get update mask. I'm going to say get paths, and it's going to return me back all the paths in that mask. I'm going to do a switch, and when I get to email, that's when I know, oh, you've provided email. I should update my email, right? If it's a mask that's not allowed, it's going to end up getting caught in my default, in which case I can tell you, hey, we can't update this mask, right? I'm going to throw you an error. So that's how you do field masks and patches, right? Pretty straightforward, works quite well, which if you were in class, I would make you work for a while, but I'm not going to do that. All right, that was a lot in a short amount of time. Any questions on G Rpc Gateway? Yes.
With the update mask stuff, what is the differences between like that update mask and what that translates to when you're in the JSON API and when you're actually doing the G Rpc Gateway versus interacting with the Protobuf itself?
So I don't know if I can call that from the G Rpc Gateway. I haven't tried it yet. Okay. I just learned about field masks here recently, so I haven't used them much at all in production. So I'm still learning them. That's a good question. That's one thing, when I wrote this, I meant to take some time and find that out. I'm just not there yet. I don't know if anybody knows the answer to that. Anybody use field masks? No? Come on, you were so helpful before. All right, yes?
How widely used is G Rpc Gateway in production, just at large?
How much is it used out there?
Yeah, just in
a
general.
lot.
A lot. Okay.
Yeah.
So
it's
very wide.
Heavily maintained.
Okay.
Yeah, and it's very robust. And the nice part about it is it's using the Go server on the back end. I mean, so it's kind of a bulletproof server on top of that. Yeah. Is it going to be as efficient as the G Rpc endpoints? No, but is it going to be pretty fast? Yes. Will it be as fast as if I'm using like Gin to write straight RESTful endpoints? No, right? But this is really more, this isn't about building the fastest RESTful gateway out there. This is about me basically only having to maintain one set of code and support G Rpc while I migrate from RESTful to my G Rpc. That's really its primary purpose. It's not meant to be, hey, if you're doing RESTful, this is what you should be doing. If you're doing pure RESTful and not G Rpc, don't do this.
How do you handle versioning between the gateway and G Rpc? In case you want to add a new field or remove it, do stuff like that.
Very carefully. So the problem with this, right, is because this gateway is kind of an add-on, is you can manage a version there different than the G Rpc stuff, right? And so you've got, what you may end up doing is creating new endpoints. And there's an entire philosophy around even RPC, gRPC, like when you actually want to change messages and change those calls. And there's an entire versioning thing. And so the Uber has a library that talks about best practice for, well, first of all, Google has best practices for protobufs. And then Uber wrote a tool that links it to enforce that you're using best practices. And part of that is your versioning semantics. So there's quite a philosophy around that. Yes?
My other question is, I saw that you have service there, they have protobuf files with .proto, and on a large scale, we have multiple service or multiple clients or multiple teams that are using this API. How do you generally distribute those files in terms of like each one needs to generate their own client or whatever?
Right.
How do you like maintain and distribute between teams?
You don't all use a monorepo? So again, you'd have to coordinate that, right? So if you're gonna, maybe you create one repo that only has Protobuf definitions. I don't know. You can slice and dice it however you want. And you can import Protobuf files just like you import Go code for the Proto C. So you just tell it using that -i command, like look in this directory. So you could easily use your own repo and use some configuration so that everybody shares the same repo. But I can't guarantee you're on the same version of that repo either, right? Like, so there's going to be some tooling around that for your team if you're not using a mono repo. But that's the case regardless, right? If you're not using a mono repo, you've always got tooling around to make sure you're on the same versions, right?
Just like a quick add, if you ever want to update like a specific property within a message, don't ever change the number.
Yeah, don't do that.
That's bad.
Yeah.
Um,
Yeah, if you read all the protocol buffer stuff that I didn't go over, it'll emphasize that pretty heavily.
The tool from Uber is called Protobuf.
Yep.
It'll say something like it's deprecated. Don't worry about it. The other tool that they say go to doesn't work. It's super new. It's called it's basically somebody's pioneering like a new protocol buffer semantic called buff, buff.build or something like that. I tried it. I couldn't recommend it for our team. So Protobuf works great. There's a Docker container for it, so if you don't want to like pollute your system, you can do it and run it. We do that at Vision. So.
Awesome, thank you. Yes.
On the other slide, you had go run with asterisk.
Oh.
Did that run multiple processes from the same command?
So this is Go. For whatever reason, they decided that instead of just go build or go run or go test and like just dot slash dot dot like the rest of the world would think, they use 3 dots.
No, on the
what?
Your terminal.
Oh.
When you spun up.
Oh, I said star. Oh, you're saying this right here?
Yeah, is that running 2 processes?
No. So what I'm doing there is I'm actually saying because I have 2 Go files in the server, right? I can't say go run main.go because it doesn't see the server Go file then, right? So this is just me saying I'm telling the run command to take all the Go files it finds and compiles them. So go run basically compiles and then it runs the built binary and then deletes the binary when it's done. So go run is just a wrapper for go build and then run the binary.
Then where's your G Rpc server?
That is running the G Rpc server. Like it literally builds it in a temporary file, then executes that binary that it built.
Oh, okay.
You
Thanks.
talked about latency. So do you have any reference number to compare against? Like
I don't have any reference numbers on latency. I'm sure there's probably some stuff out there on the G Rpc Gateway and the latency. I don't know what it is. It'd be pretty simple to measure, right? Like you could measure your latency on the G Rpc call, and then measure it on the straight REST endpoint.
Sure.
So it wouldn't be hard to figure out. Yes.
Do you have any examples for error handling or cancellation?
Yes, but not in the material I gave you.
Okay.
There's plenty of stuff out there though. Like if you just search, so basically SLAs and cancellation are handled through the context, right? So if you work with context at all, it's literally setting your deadlines from the client and then checking your context done immediately when it gets on the server. The neat thing about the way the server works is that, let me just close this down here real quick. Is the context that comes in right here actually was serialized from the client, and they actually rebuild the context from scratch, including deadlines and metadata and everything. So it feels like this context magically made it across the wire intact as a Go context. Like it's really magical. So you could just literally do something like this, check the context. This isn't how you'd write it, but right? You could just check for context.done right here, put in a select statement. If it's done, return. If not, default, keep going, right? So that's kind of how you handle SLAs and cancellations and all that kind of stuff.
Okay.
Anybody else? Everybody's had enough of me? All right. So just a few quick things here to finish out. That was field mass. That was the exercise. Oh, that's what I didn't say. I probably should have mentioned that. If you get this material, you can literally click download source here. That's not what I clicked. Download source. And then it's going to download a zip file. And then in that zip file, it opens 4 minutes. What kind of network am I on here? Let's cancel this one.
Co-working.
Yes, that's right. If you have faster internet, you pay more. All right, I'm just kidding. Anyway, if it ever opens, it has all the source files that I just had there as well, right? So you get all the code that I had for boilerplate to go ahead and play with. So that's all that. And then quickly, I just want to touch on a few things in the finalize here real quick. So if you're looking for more resources, there's a few out there. Who is not on the Go for Slack channel here? Okay, there's a few of you. I'm shaming you, I know. It's okay. You get on the Gopher Slack. There's great G-Rpc support out there. Johan, who did the talk and basically answers all of my G-Rpc questions, never sleeps. He's always out there. Literally, he's never not answered me immediately. I don't know how he does it. He's fantastic. We're very lucky to have him. Books and videos. The one I want to call out, Uber just came out with this Uber style guide. Not sure if you saw that or not. Just about Go code, which is really cool. So it really talks about like styles and things you should be looking when you're developing Go code. The internet hates me, but it'll come up. And then another one, I know I'm selflessly plugging here. DigitalOcean had us write their How to Code in Go tutorial that we just released here recently. This is a good tutorial if you have somebody that wants to learn Go and is also a new developer. So it's aimed at basically assuming that you don't know anything about development as well. So it's a really good resource, and as far as I know, the only one of its kind out there that both targets new to Go and new to development. So it's a really good resource for new developers that want to learn Go as their first language. With that, I do training consulting. If you ever want to get a hold of us as instructors, here's all our information, right? So don't hesitate to reach out to us. So thank you so much for letting me come present. I hope you gained something out of it. Question?
Would you mind putting that URL where you can get this?
Oh yes, yeah, let me put that up there real quick again. Okay. There we go. All right, so again, thanks for letting me come here. I really appreciate it. Hopefully you learned something. Don't hesitate to reach out to me. I'm usually on Gopher Slack. Send me an email. If I can help you, I will. If I put you the right person, I will. So thank you so much. If this link stops working, it means more than 50 people redeemed it. Let me know, and I'll just increase the licenses on it. So, all right. Thanks so much.
Do you prescribe to the underscore suggestion and Uber style?
No, but I have to say yes because there's a dominant player out there right now, right? So,
Fair enough.
yeah.
That one stuck out a little bit.
It looks ugly. Yeah, but at this point, don't fight it, right? Like if everybody adopts it, then it's just better. A bad convention that everybody has is better than no convention. Right? Thank you. I literally wrote those slides last week. I had to teach them this week. So.
Where were you teaching? Okay, really? I remember that's where you were last time, right?
Yeah, well, they have a huge one.
Really? How many devs do they have there?
They told me once. I don't know, I don't know how many here, but worldwide it's kind of
Yeah, no, I know there's a decent, I know a guy who's a senior on campus.
It's got to be 500,000 plus here.
Yeah, it's Austin is the second office for a lot of tech. Like Facebook's second biggest office, like Apple is. Until relatively recently, the chips rifle companies and Samsung.
Oh, sure, yeah.
Yeah, and it was funny because they were like in the middle of that litigation. They were just picking out chips.
Awesome.
Yeah, but it's I don't know, there's a lot of that kind of thing. In fact, I work for the largest software company headquartered in Austin. Here at so it's a big, it's like in our headquarters office is like far smaller than the AMD stuff that's in Austin. It's like your second
Yeah, I mean, Austin's a heck of a tech city.
yeah, we're like we don't have the entire